In the fourth task that we're going to solve, it stays as it follows. So we have three numbers that we'll be reading from standard input. That's the number n, then number m, and number k. And the task in this code is to find the first 10 numbers that are less than n. So starting from 999, 998, etc., etc., that contain the digit m k times. For example, in this case, starting from 1000, going towards the zero in descending order, we have to detect the first 10 numbers which contain the digit 9 only one, exactly one time. So these are the first 10 numbers. Here they are. Sorry. And they are printed on the screen. In solving this task, we'll also apply two ways. In one way where we'll be working only with numbers, and a second, much let's say fastest way, easiest way would be to work that with strings again. So first, let's read all of those three numbers. So n, then we have the number m, then we have the number k. And these are all read from the standard input. Now, the first goal that we should do is we should iterate in that range from 0 to n, but reversed. So we already saw that reversed function, and let's see how are we going to do it. So we will have this range. So for I in the range of 0 till n, let's print, for example, I, see what happens. Here they are. We have the first 1000 numbers, but they are in an ascending order, starting from as you can see, starting from zero. But what we want to do is we want to have it in the reversed way. So we'll just put this range into the reversed function. Now it should change. Here we are. Let's see the output. As you can see now, the output starts from 999. After having this loop written as it should be, what we should check next is so for each ith element in this loop, we should check whether, so with the if statement, count, let's define it as a function, count of digit. So we have the number and we have the digit, and this method, this function, will count for us how many times the digit has occurred in the number. So if the count of the digit in the number is equal to k, which is the number of times, yeah. In that case, we should print that number I. And let's do it first this way. This will print us all of those numbers. Then we will limit to the first 10. So let's now define that function. So the function is count of digits. And let's define it with, as we said, we are going to define it first with working just with numbers. So in that case, we are going to use this same algorithm that we already drew here on the whiteboard in some of the previous tasks. So we are going to get each digit one by one, and we are going to check, for example, if I'm looking for the digit 3. Is this 3? No, it's not. Then just delete it. Is this 3? Yes, it is. Then we will increment some counter by 1. Okay? Delete the digit. Then get the next one. Is this 3? Yes, it is. The counter will be incremented by 1 again. Now it will be 2. Delete the digit, check the number 2. It's not 3. Check the number 1. It's not 3. And we will stop when the number gets reduced to a zero. So pretty much the same algorithm, just different. We'll just have a little bit a different body in the while loop. So we'll have a counter which will be set to zero, and with a while, all until the number is different than zero, all until the number is different than zero, we'll get the last digit from the number with the modulo 10 operation, and we'll check if the last digit is equal to the digit that we are comparing with. We'll just increment that counter by 1. At the end, after the while loop, we'll return the counter. So let's test this method. As we said, we always are going to test first the methods before using them somewhere else. So count of digit of the number 1, 2, 3, 3, 4, 5. So let's count how many times the digit 3 has occurred in the number. The result should be 3 if everything is correct here. You can also see this green arrow that is moving when when the program that is running is in the given line. This took a bit longer. Yeah, it's taking long because we forgot one thing, and that's after, of course, after getting the last digit, we have to remove the last digit. Okay, so we said that number will be equal to the integer part of the division of the number with 10. Without this, our loop will become infinite loop, and that is what actually happened over here. That's why we were waiting so long for the results. Let's take a look now. We got the result instantly, and the result is a 3 over here. So it's correct. We have 3 digit with value 3 in 1, 2, 3, 3, 3, 4, 5. I'll just comment this test over here and proceed to the task. So let's see what happens now. Let's run the task. So we'll have again the same numbers, 1000, the digit 9 should occur one time. And we'll get now all the numbers starting from 999 towards 0, which contain the digit 9 only one time. One mistake, it's I over here, not number. And digit is also K. Apologies. Sorry, the digit is M. So the digit M should be located K times in the number. Here it is. Uh, so yeah, we have here 988. For example, we don't have 999 because it has the digit 9 three times. That's why it's not over here. And we have all of them. Now we should extend this code over here, which will check, we'll have a counter here as well, which will be initially to 0, and we will increment that counter whenever we find a number that has the digit mk times. And over here, before checking that, we are going to ask if the counter is already 10. In that case, we should break from this loop. Or the break statement means that we should stop the loop and go on to the next statement after the loop. That's somewhere here. We actually don't have that statement, but if we had it, the code would jump to that line. So let's take a look now. Let's take something else, for example, from 100, where the digit 8 is located 2 times. This would just give us one number. Of course, that's 88. We can also have another, even though it's not asked explicitly from us in the task, we can add another check over here. So if the counter is still 0 after iterating all of that range, that means that there is no such number. So we should probably print some message, for example, no such number. For example, if I enter here 100 and I want to have the digit A at least 4 times, which is practically impossible because these are 1, 2, or 3 digit numbers in this range, I will get the message no such number. And this is, as I said, the first way. We will now see the second way. The second way will be just actually will be only be a little bit different regarding how are we going to implement this count of digit function over here. So I will just copy the whole function. I will rename it count of digit 2 or etc. because it will be working with strings, and I will delete the whole body. So the string is a string has a method named count that is going to count for you the number of occurrences of a given character in the string. So you can just pass this digit as an argument to that count, and you can just return this. So it's only a 1-line code instead of the 7-line code that we previously had. For example, let's test it. Count of digit. As I said, the numbers, the arguments over here will have to be strings for this to work. So 1, 2, 3, 4, 1, 2, 3, 3, 3, 4. Let's count how many times the digit 3 has occurred. It has occurred 3 times, as we can see. For example, the digit 2 has occurred once, so our method is correct. So now I will just copy this whole part from here and adapt it to the count of digits etc. So count of digits etc. will be used here, but we won't be sending I and M as integers. As I said, they have to be strings. So we will cast them into their string notation so that this method could work. So let's now give it a try and see if it's going to work. So 1000, where the digit 9 is occurring twice. And we have 998, 999, actually on the first 10 numbers in that range. So let's try it with something else. Let's say 1 million, where the digit 6 occurs 5 times. And here they are. We have the first 10 of that kind over here. And that's it regarding this task and the both possible ways to solve it. As we saw, this is definitely much shorter and much readable than the first solution that we had with just with numbers.